with multiplication, like with the addition, remember we had a special element 0. It's the element which you add to any other number, and you end up with the same number. We found an analogous element in case of matrices, right? What will happen, you think, with we have a similar element with a similar behavior for multiplication, right, of numbers, right? What kind of element plays the same role with numbers? 1, right? So with numbers, we have a special element, 1. If you multiply any number with 1, you end up with the same number. Question: do we have the analogous element with matrices? Yeah. Element. Well, we do have an element. I'll show you this element. We call them the identity matrix, and we use the capital I and in the boldface for that. We use capital I in the boldface for that. And look how this matrix is structured. So that's the element with the property. If I multiply any matrix with this I from either side, from the left or from the right, and this time I have to make a distinction because the product is not commutative, the result will be A all the time. So look at how this matrix is structured. I gave you the general example. Look at this. It's the matrix which filled with zeros, with the minor exception. Every element except the diagonal ones are filled with zeros, and the diagonals one is filled with unities. This kind of choice of the appropriate size will make this happening. It's not the obvious choice. It's far from obvious. Why this is so, why this matrix possesses this property, why this matrix is truly identity matrix, and we will call it identity matrix, I'll just show you by example. I have an example here. I will use this example of the matrix. It's the same matrix from the other two slides above, the same matrix A. So if you copy that, you don't have to copy that. That's the same matrix. And the identity matrix of the suitable size will be this matrix. It will be I3 matrix. That's the identity matrix of the suitable size. So if I look at the first row here, if I look at the first row here and the first column here, if I do the combination I did before, what result of that will be? 5. So let me open the matrix here. The result of this product will be this, and that's my A matrix. That's the same, my matrix A, and this 5 element, it appeared as a combination of this row and this column. This 3 element, which is identical to my A element 3, is a combination of these 2 rows and columns. So that's why if you multiply A times this identity matrix, it will be this result. The same 3 will appear if I multiply my identity with A in the other way. If I multiply it like this, right? All I have to do to see this 3 in this way, what should I do? I should take the first row from here and the second column from here, right? If I multiply these 2 in this order, I take rows from the first factor, I take columns from the second factor. But the combination of these 2 is 3 again, right? Everybody sees that? Look, it is like obvious things, but if you think about this, guessing such a matrix like this, which will make this happening all the time, appearing the same elements, given the complexity of the way we multiply the matrices, it's not an easy guess. You should appreciate that it's a very interestingly structured matrix. Anyway, I'm not going to finish that. I mean, like, you probably get the idea by why the product of these 2 in either way, this way or this way, will be the same matrix. You can play with this, you can check, but I think that's enough on identity matrices.